Okay, so it's now my pleasure to introduce Raymond David from BASF. With these next two speakers, we had intentionally invited two different groups from industry, trying to represent the different constituencies that were out there in terms of manufacturers of nanomaterials. On the one end, which will be the first one, BASF, a huge company, but I would say out of all of the very large companies that are involved in nanomaterial manufacturing, probably the standard bearer for good practices. And so he's going to tell us a little bit about BASF's nano EHS experience. And then secondly, and I'll introduce them in a bit, we have representatives from a smaller company, but also one that's been extremely engaged, for instance, with the NIOSH site visit team, to provide insights into their experience as well. So,
thank you. Gosh, standard bearer, I don't know. I've often wondered what it's like. Often wonder whether it's better to have the talk right after lunch or right before lunch. So as the lights go down, we'll see how many can actually stay awake here. This is going to be a discussion of EH&S with a very heavy emphasis on the S, because I think that's really what this symposium is focused on, the safety procedures. And what I'd like to do is, if I can get this to work, here we go, is to try and respond to these particular questions. These were suggested as topics to try and address in part of my talk. Basically, what are the challenges we have? How do we address safety assessment as part of our business model? What are the unknowns and how do we deal with them? And in terms of regulatory possibilities, how is it that we see things working out? These are certainly appropriate questions, and I hope that in the course of this discussion we'll be able to answer those specifically. Let me start by saying that several years ago, my company developed a code of conduct in the absence of any kind of regulatory guidance. And this code of conduct was intended to get the businesses to recognize that they needed to develop nanotech products in a way that protected the worker, the consumer, the environment, and everyone down the line who had to touch these materials. It also got them to commit to research on the hazards of these materials and to be able to communicate that to the general public, because as you saw in Patricia's talk before, there is a real concern on the part of European companies about will nanotechnology go down the path of GMOs, genetically modified foods in particular. And certainly European companies are much closer tuned to this than US ones. I need to make a comment here. Code of conduct is a particularly European concept. It's not necessarily something that we would do in the United States. We would say we would follow responsible care, for example. And the other thing that you have to understand is that a large corporation like BASF is not a top-down organization. So in other words, there is not a dictum from the Board of Trustees that then goes to all the businesses that they follow. They have to actually sign on to this. Each business runs virtually independently, and that's important. And yet, all the businesses signed on to this concept. About a year or two ago, we formalized that into a guidance document that covered not just nanotechnology, but all of the products. So it was a matter of how do we deal with all our chemicals? How do we take care of the assessing the risks to the consumer, to the workers, and developing products that make sense? Nanotechnology is highlighted in this. It has a totally separate section that talk about risk assessment, that talk about hazard communication. And so how do we do that? Well, we've organized within our company a group called the Nano team. And that's made up of representatives from the various business groups, from the R&D facilities, any department that has an interest in nanotechnology. And at that level, and especially from the regions, at that level, we discuss what the issues are with respect to nanotechnology, and we make recommendations. And those recommendations then go to the Nano core team, a select group of senior management that reviews the recommendations, and then based on whether or not they accept them or not, will pass them on to the board of directors to be incorporated as BASF policy. We also try to develop products in a way that reduces the overall risk. Now, you've heard several times already that risk is a matter of hazard and exposure. So if we make just this simple diagram trying to show where we are, where we'd like to be, obviously we'd like to be down here with the lowest hazard and the lowest exposure. But quite frankly, not all products fall into that category. I mean, we look at composites here, in spite of what we heard this morning, as falling into this category, even though they might have a highly hazardous part of the composite. If one looks at, say, sunscreens, well, clearly there is a very large exposure to a very large population. What are the kinds of, but the hazards, as we can know them now, are fairly low, at least for dermal exposure. But it would require a certain amount of data development for us to continue with that product. Conversely, if we have a product, let's say a carbon nanotube that might have a much higher hazard, we want to make sure that the exposures are reduced for the worker here and in the final product here. Well, obviously what we want to avoid is something up in that upper right quadrant that has a high risk and high exposure. And how do we do that? Well, when a business is in the process of developing a new product, they are required to submit that information to the toxicology group to do an assessment, a screening level assessment. And if that comes back and says, well, gosh, we don't see any risk here, expected, then that gets communicated back to the business. If there is a potential for a risk, then that will trigger then additional pieces of information, either with respect to exposure assessment, whether it be the worker or the consumer, and toxicity studies. And then that goes into a detailed risk assessment, which could then lead to the conclusion of, again, no risk, or some kind of risk management policies. When we do the hazard assessments, and I think some of you have seen this slide before, what we've tried to do within the company is come up with a rational approach to screening our substances. It's not possible to conduct long-term, life-term studies on every substance. That's simply not practical. So we've taken a different kind of an approach, one that tries to be as realistic as possible, using preparations as they would be used by the consumer, for example, and conducting several different kinds of studies depending on what the likely route of exposure is. So inhalation, in addition to pulmonary endpoints, dermal penetration studies, genotoxicity to see if there might be any long-term effects, aquatic tox, and as much as possible, developing some kind of a family approach. I think Paul mentioned already that you can't paint all substances the same way, and you certainly can't test every substance. So we have to come up with a way in which we categorize things. Having said that, I'm not sure that we've come up with the best way yet, so don't misunderstand me. One of the key aspects to this is to make sure that we characterize the substance, the neat substance, as well as the substance, how it is used, because its behavior can be different, much different biologically. The areas where we've been looking at hazard, obviously the skin, whether or not substances penetrate, the lungs, whether they're taken up and whether they cause any kind of pulmonary damage, looking at the distribution and kinetics, genotoxicity, how they interact, if they interact, and under what test systems they interact. a bacterial cell might not be the most appropriate way to assess genotoxicity, for example. Looking at the environment, and in all of this, trying to come up with the best test methodology that can be used and could be used on a regulatory basis. So we feel that we have a plan for the hazard assessment. What about exposure assessment? As I said, sunscreens are something clearly have a very broad exposure. And we have done studies within our laboratory to look at the penetration of sunscreens through intact skin. We use the pig as a model because it is much closer to human skin than, say, a rat skin is. We've tried not only abraded, or not only intact skin, but also skin that was damaged, sunburned skin, in other words, as you might get from an overexposure at the beach. Looking at TiO2 and zinc oxide, we can't detect any penetration beyond the epidermis for these particular materials in the formulations as they are used. Oop, I did something, sorry. Inhalation exposure, certainly we have looked at inhalation exposure of carbon nanotubes as such, but we've also tried to identify whether or not carbon nanotubes can be released from composites by abrading, shearing, and we cannot detect any carbon nanotubes coming off from those composites. For workers, we have to take a slightly different approach. The first thing was to develop an inventory of materials that are being used within the company that would be considered nanomaterial. And one might think, well, that should be pretty simple, right? You just look at the label. You can't do that. You can't go to the plant and ask the plant managers, are you using nanomaterials? They don't know. There's no way to identify them. So it takes quite an effort to come up with the product names, the identity, the size distribution, which groups are using them within the company, and sometimes within a large company as ours, one division might make a nanomaterial or a product that has a nanomaterial and sell it to another part of the company. It never leaves the company. And of course, much of that is dependent on the definition, and we'll discuss that more in a moment. Having completed a global inventory, we then said, okay, well, what's the next part that we have to do? The next part is we need to develop a registry of who is involved with dealing with these nanomaterials. I know there's been a lot of discussion about whether or not medical surveillance is appropriate. Paul was spearheaded a discussion, a conference during the summer about medical surveillance of nano workers. My company does not feel that surveillance specific to use of nanomaterials is appropriate just yet. But we do believe that developing a registry, identifying who is involved, is appropriate. And so we're doing that now. What we will do is once we have the people identified, we will then compare their medical histories, we will follow them, we can tag them into the system, and as appropriate endpoints are developed, we will then do the medical surveillance. And the last part is to do the actual exposure assessment. And of course, once we do that, I mean, there are different ways to do that. You have the qualitative data, you know what the grouping is, you have to identify based on work area, based on work activity. There are different ways in which to do the actual metrology, and it will be important to capture the chemical identity. So let me give you a sense of what happens here. This is the timeline that we set up for ourselves in doing the inventory and the registry part of the activities that I just showed you. You can see it's almost a year and a half, and we're somewhere down here. Why does it take that long? It just, when you start to ask the questions, it just takes a long time to gather the information. And developing the registry, I keep pushing something. Developing the registry again, is the same kind of issue. We've gotten our initial response. We need to go back and double check with the plant managers to make sure that they have answered appropriately. And for the exposure assessment, we've developed a tiered approach, much like the one that is proposed by NIOSH, developing information based on different tiers of just information, qualitative measurements, some very crude metrics for an actual assessment, followed by a much more detailed or extended assessment. And each of these tiers is based on some decision point. Decision points are, is there a substance-specific TLV or OEL? You've heard Paul say already that there really aren't that many. There are some proposed, but there aren't any. If there are some, they're probably not nano-specific. So we've come up with our own intervention value that is very crude. We say if it's significantly above background, and one might ask exactly what is background, that's an important part, then we would go in and do more metrology. Also, it would depend on the chemical identity. So until we can get better exposure levels in the workplace, acceptable ones, this is the plan that we are going to use worldwide. And it's as part of any kind of registry, as part of any kind of exposure assessment, it's important to have some information that goes back to the worker. I mean, these people are going to be tagged somehow. They need to understand, what does it mean that I'm working with nanomaterials? So on our website, we have a few documents that we feel are appropriate. We do have a link to the Good Nano Guide. This is just the beginning. We plan to put more documents on there. We have a number of different safe handling procedures that we are developing at this point. And the safety data sheet, which I will admit is under construction. It's under construction because we do have nano-specific phrases that we are putting on our safety data sheets, but it's not as simple as you might think, and I'll show you that why in a moment. Safety procedures, and we want to make sure that this is consistent with the ISO draft procedures that have been proposed for safety data sheets. Now, the safe handling procedures, this is not anything terribly earth-shattering. This is just good industrial hygiene practices applied to the use of nanomaterials. So you want to reduce the ability to create dusts. You want to be able to reduce the dermal exposure as much as possible. As much as possible, use engineering controls. And if you can't do that, then somehow change the procedures that how people are working these materials. As much as possible, we try and manufacture or use these things in a closed system. If that can't be done, then see what other procedures you can use to reduce the exposure. And in all cases, we will try and monitor the workplace as much as possible. Now, what are the challenges? And I think this is where we will get into the discussion later on. As I said, one of the issues is, well, what is a nanomaterial? I mean, the businesses, we can go to the business and say, are you using nanomaterials? They say, sure. What is a nanomaterial again? Well, if we look at this and say, anything that's unique and it's 1 to 100, well, that's a small number. If it's just 1 to 100, well, now we're talking printer inks. If it's something that includes agglomerates and aggregates, well, now we're talking about sunscreens. And if we're talking about a nanostructure, so let's suppose I put something into concrete and I put it on the surface of a building or a catalytic converter, well, now we have a whole lot more substances. Are all of those going to be included? And where will the regulatory definition come in? Is it going to be here to include all those substances that I think everyone would accept to be nanomaterials? Or does it fall up here? That's a question we need to answer. The other part is nanoparticles are not one size. They are distributed in size over a range. This is an example of something that I think is clearly a nanomaterial. Almost all the particles are within the nano range. But is this? I mean, we could have a particle, and we do, that has a distribution much like this, where the median is much higher than 100, and only a small portion of it falls below 100 nanometers in the nanoscale. Is this entire thing going to be included as a nanomaterial? That's something that we need to come to grips with in terms of definition. Because there are people in Europe, for example, that have proposed that this percentage in the nanoscale region could be as small as 0.15%. If we do that, we're going to be counting dirt as nanomaterials. Other challenges are that in trying to identify what nanomaterials we use, there is no common way to identify them. In other words, we have to look at the raw materials and say, are these or are these not nano? It's not exactly identified on the safety data sheet necessarily, or even sometimes in the technical specifications. The analytical methods, we need to come up with a good metric on what to use in the workplace. I think milligrams per cubic meter or micrograms per cubic meter is nice. It's something we always use, but it's probably not appropriate. We need to translate that into some particle count. We need to translate that into something else that is easily measured. Particle count is easily measured, although how relevant it is, I think we can have a discussion about that. And certainly there are various exposure assessments that are available. We need to come to some consensus about what that is, as well as guidance documents. There are a whole lot of guidance documents out there. In the absence of some consensus, we will develop our own. We found that in going through this exercise, we really had to come up with a global interdisciplinary team. Now, this is something that large companies have to deal with because, first of all, the global aspect. I mean, I work for a U.S. company that has a European parent. That's not unusual. Many large companies are that way, and therefore there is a certain how shall I put it? There's a certain reality that we have to deal with from one region to another and trying to come into harmony. So in order for us to do our job, we had to gather together members of each of these various disciplines on a global basis so that we could develop our inventory and have a harmonized approach so that when Europe says they are going to conduct exposure assessments this way using this kind of metrology, this kind of instrumentation, the people in the U.S. have to say, well, yes, that's what we can use because we have exactly that equipment. In some cases, that's not true. And the IT infrastructure is a challenge. I'm sure that all of you have walked through an airport and seen some large company that uses SAP. Yes, we use SAP. And you know, there is no way to identify something as nano in SAP. You have to create that. How do we tag that? How do we determine, for example, on a safety data sheet for TiO2, whether the nano-specific terms that we want to put on the safety data sheet are going to be for the pigment-sized TiO2 versus the nano-sized TiO2 that's going into a sunscreen? That becomes a challenge. And these are some of the unknowns, I think. We've already heard a little bit about waste treatment. What happens to that waste? Where does it go? How do we deal with it? A safety data sheet, what's on the language, and OELs. From my perspective, large companies are probably in a little bit better position to deal with these, or at least some of these. Many large companies, most of us, have our own water treatment facilities. So we can at least monitor and control what goes in and what comes out. That may not be true for all companies. On a safety data sheet, we continue to try and develop specific phrases, but as I mentioned, making sure that they go with the right product can be a challenge. And for OELs, we're developing our own strategy. We'd like to be able to work with government agencies as much as possible to develop a plan, a strategy for OELs. I know that at OSHA is beginning to put together a guidance manual, and I hope that there'll be some opportunity to have input into that. So going back to the questions of interest. How am I doing? No problem. These are the questions that were posed originally, and I'd like to suggest that these are the answers to the questions. BASF, I think, is recognized as a company that is developing safety information on nanomaterials and trying to develop workplace practices that make sense. The challenge is to harmonize them globally, I should say, both internally within the company and externally within or for the regulatory community. It really does not help if we have different kinds of OELs in different parts of the world. That's not helpful at all. We do focus on the safety of nanomaterials in our product development, and that is focused on the worker and the consumer. We large companies, I think, have probably a better understanding of dealing with unknowns than, say, smaller companies do. Only because we've done that with so many chemicals up to this point. We treat them as the worst possible things until we know better. And we would look forward to engaging in dialogue with the regulatory community, with the legislative community, and trying to come up with regulations and statutes that would make sense. I think that that's going to be a challenge. I'd like to see us move forward in a concerted effort. So with that, I thank you, and I'll be happy to answer any questions.
Regarding the hazards of these nanomaterials, when it is transferred to the person, let's say to the patient, when he gets, let's call it polluted, nano is polluted. What are the means to help the individual who has got this pollutant in the system to help get rid of it till the further assessments are made to the hazards of these nanomaterials?
I'm not aware that there are any methods right now to eliminate nanomaterials that have already been somehow incorporated into the body. I mean, unlike some chemicals that can be purged by treatment with, let's say, chelators or something else, I'm not aware that there are any such remedies.
I mean, are there any research going on in this field?
Not that I am aware of. Certainly not that I'm aware of in my company.
Any questions from the web audience?
Hi, we have a question from the web. It says, I'm from a county emergency management agency, and I'm wondering if you could speak to the practices in working with your off-site emergency responders and hazardous materials response teams in responding to nanomaterial spills or releases.
To the best of my knowledge, our emergency response group does not have any nano-specific instructions. So they would first look to the chemical nature, and then typically what happens is that they approach the product stewards from the businesses who are in EH&S and ask them for more information on what forms that particular substance might have.
Can you describe the interactions with BASF and customer relations and maybe public perception regarding some of the products that you have in development? Are the perceptions preconceived as negative, or is it pretty fair-minded?
In Europe, they have engaged in what they call a dialogue with other stakeholders. I think it's a particularly European concept where they get stakeholders, all kinds of stakeholders together and discuss the issues. So I know that my company has been involved in that. In addition, we have identified products that we would like to at least engage in further dialogue. So in other words, if we use a product on the surface of a building and it has a particular advantage, well, we want to explain that to the general public. And so that activity is going on certainly in Europe, and perhaps will spill over to the U.S. Now, other than that, I'm not aware of any kind of dialogue with consumers or other stakeholders other than, say, symposia like this.
So I just have a question about the idea of benign by design we were talking about earlier. And I would imagine as a larger company you would have resources available to be able to sort of treat the redesign of potentially toxic or hazardous materials. And you mentioned screening level assessments. And I just wonder, through those screening level assessments, can you gather enough information to determine what sorts of things you could do to possibly change the hazardous properties? And is this something that you actively do at BASF?
Well, I'm probably not the person to answer that last part about whether we are. I do know that we are very definitely looking at the risks of particular substances, and if there is a way to modify those risks, we will do that. Now, in some cases, just the way we use a product will modify the properties. So, for example, a sunscreen like TiO2 or zinc oxide gets coated before it gets put into a formulation, and part of the reason that you put that coating on is to reduce the surface reactivity, which would then reduce the biological activity. Now, whether or not we would do that, say, we don't make carbon nanotubes, but if we did that, if we modified carbon nanotubes for that, that would be a possibility as something that they would look at. But whether or not that's actively ongoing, I can't answer.
We have another question from the web. Are there differences between OEL of MWCNT from NIOSH and Bayer nanotubes?
Gee, I don't know. I mean, we have set out an internal OEL for carbon nanotubes based on the information that we developed ourselves. That's the only internal OEL that I'm aware of. The other, what we call intervention value, is a very crude number. It's just, X number of times above background, and it's not substance specific.